Question 9. The positive constant a is such that this integral here between these limits gives an answer of 0. Show that this equation, this cubic equation, is true. So the first bit is just about integrating between the limits. It's a bit different, isn't it? Because normally we get told the value of the limits and we have to find what it's equal to. So this is working the other way around. But we'll just take it step by step. Our problem here, of course, is that at this stage we don't really know how to deal with fractions when we're integrating. What we want to do is to get it all on one line, in index form. So let's uncommon denominatorize this fraction. Let's think about it instead as being, well, 2x cubed over x squared, which just cancel down to be 2x, minus 5x squared over x squared, which just cancel down to be minus 5, and this is 4 over x squared, which I think I want to write as 4x to the minus 2. So I want to write it like that. Now I'm ready to integrate carefully. Remember we did it between square brackets now once we've done that. 2x. What's 2x going to go to when we integrate it?
X squared.
Just x squared. Because the 2 will cancel out. What will 5 go to?
5x.
5x. And careful again with this, 4x to the minus 2. What's that going to integrate to? Minus 4x to the minus 1. We've added 1 to the power divided by the new power. So it's 4 over minus 1, which is minus 4. Between a and 2a is equal to 0. Now we can sub in those limits. We'll put the top one in first, we'll put the 2a in first. Now again, really, really careful about squaring this. 2a, when we square it, is 4a squared. This was a mistake that a few of you made, that you squared 2a and you got 2a squared. But if we square 2a, we get 4a squared. 5 times 2a is 10a. And this is minus 4 divided by 2a. And we'll deal with that in a moment. Then we're going to subtract what we get when we put a in. That's a squared minus 5a minus 4 over a. And altogether that's equal to 0. We need to tidy this up a little bit. What have we got? We've got 4a squared, but we take away an a squared. That looks like 3a squared. We've got minus 10a minus 5a. So that's negative 10a, but then we're adding 5a to that. So that's minus 5a. I'm just going to go a bit steady with this bit. This bit we've got minus 2 over a there, and then we've got minus 4 over a. So we're adding on plus 4 over a there. I'm just going to take an extra line to make sure I've got that right. So this is 3a squared minus 5a plus 2 over a is 0. Minus 2 over a plus 4 over a will give us that. Are you alright, Henry? With that? Yeah. We've got an a on the bottom of this fraction, so what we're going to do, times everything by a, 3a cubed minus 5a squared plus 2 is 0. That's what we were supposed to be getting. Yay, great news. Let's say quiet. Right. As I said, it was really nice to see how many of you, even though something had gone wrong in here, persevered and used the quoted equation in part 2. So part 2 now gets into dealing with the factor theorem. Part 2 says that 3a squared minus 5a squared plus 2 equals 0 has a root, show that a equals 1 is a root of that. So we're going to set up some nice notation for this. We're going to say that f of a is 3a cubed minus 5a squared plus 2. If we want to show that a equals 1 is a root, we're going to evaluate f of 1, that's 3, minus 5 plus 2. 3 take away 5 plus 2 is 0. Therefore, a equals 1 is a root. And actually, I'm also going to write a minus 1 is a factor. Because that's what it means, doesn't it? That if a equals 1 is a root, then a minus 1 is a factor of our equation. It then says, hence find the other possible values of a. Find the other possible value of a. Actually, I read that wrong just then. But look, the other possible value of a, value singular. So let's notice that and keep that in our mind as we go forward with this. So a equals 1 is one value. You've now got your choice about what you do with this, and one choice is to do long division. Long division is playing it safe, as long as you're good at long division. Because long division, you make sure you're going to get the method marks for attempting long division. I didn't do long division. Oh, that's not good. I thought if a minus 1 is a factor, then I can figure out the other factors because I'm good at this kind of thing. So the other factors, at the start of this bracket, it has to be a 3a squared. So we need to end up with 3a cubed. At the end of this bracket, we're supposed to have a plus 2, so it will be minus 1. This must be a minus 2 here to give us that plus 2. Now we can either do a little bit of algebra for the other bit, or we can think it through in our head. To get 0 a's, because there are 0 a's in this bit, the only way I would multiply that to get an a term, I've got minus 2a from there. I need minus 1 times this bit here to leave me with 0. I've got minus 2, minus 1 times minus 2 would make it plus 2, that would get me there. That must, I just said minus and not plus. That must be a minus 2a in the middle. Let's check it. We're supposed to have minus 5a squared. We've got minus 3 of them from that bit. This would give us another 2a squared to take away. That's the minus 5a squared that we want. If you do long division and do it right, you get this thing in the bracket as well. Even if you do long division, I want to urge you to check your answer from long division by multiplying it through and just making sure it makes sense. Because long division is, there's plenty of spaces to make mistakes in that under pressure in the last question of the paper. Right, so what we've got is this is factorised, let me just, as being a minus 1, 3a squared minus 2a minus 2. We were already told that a equals 1 is one of the solutions. So we don't need to worry about that anymore. Another solution is 3a squared minus 2a minus 2 is equal to 0. Now that isn't going to factorise, is it? So, and we already know it's not going to factorise because the answer said give your answer in simplified third form. So that's a pretty big clue that it's not going to factorise. We could try and complete the square, or we could just dive straight for the quadratic formula. So let's do that. A is minus b, so minus minus 2 is plus 2, plus or minus the square root of b squared, minus 2 squared would be 4, minus 4 times a times c, all divided by 2a. Let's not rush into this. 2 plus or minus, what have we got here? We've got 12 times 2, so that's 24. So we've got 4, take away minus 24. So 4 plus 24, we've got 28 in there. And here we've got 6 on the bottom. 28 is 7 times 4. 4 is the biggest square number that goes into it. So this is A is 2 plus or minus 2 root 7 over 6. Divide that through by a common factor of 2, top and bottom. And there we have that. So we have 1 plus or minus root 7 over 3. That looks to me like two values. But I remember that the question said a equals 1 is one value, and then remember that singular, find the other possible value of a. So what's going on with this? What could there be about a that means that we need to reject one of those? And we quite possibly missed it in our haste to get on with integrating. But up there it says that the positive constant a is such that gives us that. A is a positive constant. Whether or not we stick this into a calculator and turn it into a decimal, I think we know enough to know that root 7 is a good deal more than 1. So 1 minus root 7 is going to be negative, isn't it? So the only value of a that we found, in addition to a equals 1, that is valid, is 1 plus root 7 over 3. And we have to, at the end of this question, we have to actually actively identify that as being our other value. Okay, we have to give only the positive root. If we give both of them, we leave our answer like that, we're not going to get the final mark for this. And all of the people, all the ones that I marked, however good they were, even the perfect ones, didn't get that last mark for rejecting the 1 minus root 7 over 3. Okay? Thanks, Andrew. Great work.
Cheers.